So students, things keep changing around you, whether it is growing of a plant or burning of wood or even eating food. Things around us keep changing in size, shape, structure. They keep absorbing energy and therefore create new substance. In chemistry, most changes are divided into two categories: physical changes and chemical changes. Let us define what physical change and what chemical change is. Physical change, as you can see on your screen, are those substances where physical properties of a substance change. That is, no new substance is formed. The substance undergoing change does not change its identity. And in most of the cases, they are reversible too. Like cutting of a cloth. You cut the cloth, but ultimately it remains the cloth itself. Only the size and the shape changes. The changes in the physical state of matter is a kind of physical change. The ice is heated, it melts to form water. The ice and water looks different, but they are both made up of water molecules. Thus, no chemical substance are formed during the melting of ice or even evaporation of water. So, melting of ice to form water is a physical change, and so is evaporation of water to form steam. Now, before discussing more example of physical change, I would like to introduce another terminology in front of you, that is physical properties. These are the characteristics of a substance that can be measured. Now, let us see what are those characteristics that can be measured. See, the state of matter at room temperature, whether a matter is in solid, liquid or gas, it is a physical property. Boiling point, melting point, the color, density, all these are physical properties of a substance. Another one is hardness. It is the resistance of a solid to being scratched or dented. This property again is a physical property. Then we have malleability. Then we have ductility. Malleability, as you can see, describes how easily a substance can be hammered or bent into different shapes. This is also a kind of physical property, and we have discussed this physical property in detail in metals and non-metals. Why they are malleable, why they are ductile, all this has been discussed. Ductility is the property in which the substance can be pulled out into wires without snapping. Snapping means breaking. Without breaking, that can be drawn into wires. This is again a kind of physical property. This has been also discussed in metals and non-metals. You pull it from both the sides, you can get thin wires. Now, let us come to examples of physical properties. More examples like solubility. That is, ability of a substance to dissolve in a solvent. Solubility has been also discussed. This is also a physical property. Then viscosity. Viscosity is resistance. It is a property that describes how quickly a substance flows in its liquid form. Understood? So this is viscosity. Water has got less viscosity than honey. The change of state of matter, as discussed before, is a physical change. A few changes, that is, can be undone. Say, while dissolving sugar in water, ultimately they just form a solution of sugar and water. There is no chemical change. It retains the individual property of sugar as well as water, and we can even separate them by simply heating them, and you will find that the water will evaporate, leaving behind sugar. Say, while baking a cake, let's mix butter, flour, egg, sugar, even milk. There is no practical way of separating the constituent, but still it is just a physical change. The chemical change occurs when you put this mixture in the oven and add heat, and therefore this changes the aroma, the smell, the color, and even the physical properties. Even gases are released, which is what helps the baked good to rise. Finally, these changes cannot be undone. They cannot be reversed back. Such changes are called chemical changes. So a change in which the particle rearrange to form at least one new substance is called a chemical change. These changes are generally irreversible in nature, like burning, combustion. It is an example of chemical change. These are permanent changes. If you burn a piece of paper with a lighted matchstick, then the entirely new substance like carbon dioxide, water vapor, smoke and ash are produced. Burning of charcoal, burning of fuels like coal, wood, LPG, burning of hydrogen and oxygen to form water, metals rusting, fireworks exploding, growth of plant, cutting of trees, digestion of food, all this comes under chemical change. Many a times we are unsure whether a change is a chemical or a physical change. In that case, you need to understand a few clues. These are signs of chemical changes. Like, chemical changes always form a new substance. In chemical change, either the heat is absorbed or released. There may be a change in color. They may produce odor, create sound, release gas, even produce light. These chemical changes are permanent in nature and cannot be undone. Before we can proceed and compare the chemical and physical change, let us also talk about chemical properties. These are the properties that describe the ability of a substance to react chemically with another substance to form a new chemical. So to see a chemical property, a chemical reaction must take place. As you can see on your screen, chemical properties can only be seen when a chemical reaction happens. And chemical reaction is not a new term for us because we have discussed the different chemical reactions in the chapter metals and non-metals. Now let us discuss a few examples of chemical property. If a substance is combustible, that means it will react quickly with oxygen and produce heat and light. If a substance is acidic or basic, that also describes how it will react with other chemicals. Now let us compare the chemical and the physical change. When a new chemical substance is created, it is a chemical change. Say, when two hydrogen reacts with an oxygen, hydrogen and oxygen are gaseous. They have got different properties. They form a new substance, water, H2O, which again has a very different property from both hydrogen and oxygen. If the chemical are not changed, it is a physical change. That is, the chemical remains the same. Ultimate internal structure of the molecule remains the same. That is change of state. When a liquid water changes to a solid, that is ice, it is a physical change. Let us look at some clues that will let us know whether a new chemical is created or not. And we have discussed this before also. A new color appears, heat or light are given off, bubbles of gases are produced, or solid material, that is in the form of precipitate, may appear when two liquids are mixed. The change is difficult to reverse. It is generally irreversible. It cannot be undone. So now let us look at a few examples which will help us to find out whether the change is chemical or physical. Baking a loaf of bread. What kind of change do you think it is? A bread which is baked in the presence of heat. Heat is absorbed. Gases are released, structure is changed, aroma is changed, shape is changed. It is a chemical change. Now let us discuss another example. Cutting this slice of bread. What kind of change is it? Is the cut slice of bread, there is a change in their chemical property? No, ultimately it remains bread only. Therefore, this is a physical change. It is not a chemical change. Now applying peanut butter on this bread. Well, on this one, what happens is that the appearance of the bread changes. But ultimately, peanut butter remains peanut butter and bread remains bread. There is no chemical reaction between the two of them. Therefore, it is a physical change. Let's go to the next one. Setting the bread on fire. Now this is actually generally not done, but we have just taken one example. When we set this bread on fire or when we burn it, burning a candle wax, burning a bread, burning a wood, combustion is a chemical change. Let us look at the next one. Mixing red and yellow paint to get orange. We generally mix paints to get a new color. Even though the color is new, but yellow and red, it retains its property. And therefore, this is a physical change. No chemical reaction takes place here. Okay? Now let us discuss some other example. That is, the molecules that make up the paint has not changed. Let us look at the next one on the slide. Now turning on the light bulb. When you are turning on the light bulb, heat and light is produced. These are the clues or signs of chemical change. But it is very easily reversible. You can switch off the light simply by pressing the button. So it is a physical change. Next we have frying an egg. In this case, there is a change in the color, there is a change in the shape. It cannot be reversed. It is very difficult to reverse. It cannot be reversed simply. So again, it is a chemical change. Okay, now let us ponder on this slide. This shows the difference between the chemical and the physical change. Physical change, as you can see, no new substance is formed in physical change. A new substance is formed in the case of chemical change. It is a temporary change. The other one is a permanent change. A physical change is easily reversible. A chemical change is usually irreversible. Very little heat or light is usually absorbed or given out. A lot of heat and light is absorbed and given out. In case of chemical change, the mass of the substance does not alter in a physical change. The mass remains the same. The amount of substance remains the same. But in case of chemical change, the mass of a substance does alter in a chemical change. This is all for today. Please review through the lecture. Take care and stay safe.